Buenas tardes. ¿Me escuchan? So I have had a cold and I lost my voice, but I think I can do this lecture if we review the test. And then and then on Wednesday we can start the new material. The new materials, Unit 3, and I've posted it already up into Moodle. Honestly, that takes 1 week. That's it. So you can get started with those documents. Let me make sure I'm telling you the truth. This is, oh, I just started posting. I put the lecture notes and I'm preparing the assignments as well. I put the lecture notes, a summary of the lecture notes, and you can start reading them. So next class I will maybe, depending, I have a conference to go to on Thursday, and I'm actually thinking I have to leave early, maybe Wednesday night. So I might just post the video for the instructions on Unit 3. Not the instructions, the lecture on Unit 3. It should be 3 hours. That should cover the material there. And then you can get started on the review. The longer, so I've only put a date of March 8th. Why have I put a date of completion March 8th? I think you need till next week. I have to change that. I gotta change that. Let me show you on the platform. Okay, I'll just go to the platform while I wait for people to show up. How many are here? You hear me? Yes? The sound is good today, right? I fixed it. I've changed rooms, and so I had to adjust the settings on the microphone. My cold. So I just wanted to outline what I did. You can see this, right? So this is the platform. You have that assignment to finish. So I'm going to change, this as chapter 8, March 8th. I'm going to change that till next week. So you should finish Unit 3 in a week. It shouldn't take that much time. All I have posted right now are the lecture notes and a summary of the lecture notes, and I'm going to put some exercises up today. All right? And then there's a video here. I have an old video. I think I have to suppress that too. All right. I have to clean up your website a little bit. Okay, so I'll fix those. But today I wanted to look at the test together. So the test was done well. I mean, you found the problems that you could do. It was in a short time. I have to congratulate you for using the time efficiently. Some people wrote me some questions. There were a few emails asking about the grading, and I haven't had a chance to get back to them. I haven't been well. I wasn't well this weekend. Sorry. And the end of last week. I will get back to you about that. Mostly what I did was look at your support, your evidence. So if you even picked the right answer, but you didn't have the right evidence, I didn't give you credit. But if you want to discuss that with me, we can talk about that. So I have a couple of meetings already set up. So make a point to contact me by email and we'll set up an appointment for that. Yes, Del Valle. Okeki. Is that how you pronounce your name? That's fine. You can send it again. Sure. I did see it, but I didn't respond. I've just been so unwell, but I am getting better. So let's get back to the exam and do the problems you didn't do, as well as the ones that you did. If you don't hear me, let me know because my cable is a little loose on my microphone. So just let me know if you have trouble hearing me. And the sound is good. I'm not kidding myself, right? It does sound good. Professional. All right, no video today. Just I'm going to just show, no video of me. I'll just show the pages. So here's the first problem. I think it was pretty clear. Some students tried to send me the set of their solutions, handwritten solutions. They sent them late, and I was quite generous. But if you sent them like a day late or really late, I wasn't really happy with that. So you have to send your handwritten solutions. You have to submit them together. Yes, Alejandro, that's all. That's the assignments, right, for next week. Or for tomorrow. Sorry, yes, for tomorrow. So, and then and then for by next Wednesday, you should finish Unit 3 review. So I can start to put some questions up and connect for that. And so by next Wednesday, we should already be doing Unit 4. Okay, any more questions? Okay. Yeah, Alejandro's correct. I just coordinating because I'm watching my presentation, even though it's delayed. I have to watch it at the same time as a live stream. All right, so to help pay for your new house, you have approached the bank for a 25-year, $95,000 mortgage. The bank quotes you a rate here. So this is a quoted rate, and I tell you that it's per year compounded monthly. Now, I don't even, after this class, after now, I don't even have to tell you that. Because if it's a mortgage, you should know that it's per year compounded monthly, okay? That's, if nothing else is written, if this just says, bank quotes you this, you need to know that it is a stated rate Let me put this down. 1 minute. You need to know that that's just a stated rate. Simple interest. Stated over the year, but compounded monthly. Somehow I don't see the chat. Why don't I see the chat? Oh, here. Okay. Too many screens. Okay, so that is 6.6365. And then you're told that after you've made the payment at the end of the 15th year, what is the amount of principal remaining to be paid? So this is a mortgage. Mortgages are paid monthly. So it's a loan and it's repaid monthly. So I need to convert everything, convert all variables to months. So we're going to begin with the rate needs to be the effective monthly rate. And I saw that many of you were just using the formula very, well, in this case, all you have to do, it's not, so some get confused. Basically, you just have to take it and divide it by 12, right? You got to take the rate given by the bank or financial institution and divide it by the number of compounding periods in a year. That's simple. And you hopefully did that. So putting that into your calculator. Just like that. Now, you need to keep all those decimal places, so store it, keep a record, store that in one. Remembering it's a decimal. We're going to have to multiply it by 100 to put it into the time value of money keys as a percent. All right, so that was that. Now it's a 25-year mortgage. So this is how you figure out how many months you have, right? You multiply by 12, which is 300. So we have the duration, we have the rate, and we need the payment. Aha, we don't have the payment, but we do have the amount of the loan, the $95,000. How's the sound? No one commented. Is the sound clear? Is it echoey? It shouldn't be. Very perfectionist. Okay. All right, so we realize we don't have the payment, and we're going to need the payment to do this, to answer this question, because we need to know what is the payment, what is the principal amount that remains after the 15th year, right? That's what I want to find out. So let's write that down. We're going to need, so after the 15th year, in other words, turn it into months. 15 year equals 15 times 12. It's 180 months. So that leaves 120 months of payments. So what we're going to have to do to find the present value at 120 months, one month before the next payment, is to put the payment amount in here, and then using the monthly rate in an annuity for the remaining period, you should be able to find the principal, the balance. But the issue is you don't have the payment. So we're going to need that. And then once we have that, we can do this. So how are we going to find the payment? The payment is found with the other information. So with the other information, we know let me put it in a different color. So to find the payment in blue, we're going to put together all this information, which is that 95,000 is equal to an annuity with that payment, that rate, and the entire mortgage term, which is 300 months. So this is the first equation you have to write to find the payment. And the way you're going to do that is use your keys of your calculator, right? So you're going to put in from left to right 300 as the years or periods, payment periods. The interest, I'll recall 1 times 100. For PV, it's 95,000. You put it as a positive because you get that. And then you call for the payment. You compute the payment, put 0 in FV. So let's do that. So I can, just to be sure, I can clear TVM. Entering 300. I actually don't have my rate in this calculator. Let's put that number in. So let me do that calculation. If I put 6.6365 divided by 12, that leaves it as a percent, and I can put it right in there. Is that the number that I got? Yep, that's the number I got. The PV is 95,000. I'm going to put 0 in FV and compute the payment. That's the payment. Payments for mortgages are in dollars and cents. So we just take $649.57. You don't keep all the decimal places, right? Because payments will be actually in dollars and cents. So I'm going to say, again, using the same color coding, this will be the same payment in here. So now that you have that payment, all you need to do is change the years to the duration to 120, because this is what's going to remain with that same payment and that same interest rate to know what the balance is. So that's what's left. Remember, You can look at a mortgage, or sorry, you can look at a set of cash flows at a point in time. So we're looking at 120 months, or you can call it 15 years. And you can think, how much did I pay off? So that's one way to do it. You would find the future value and subtract it from the amount to be paid, but that's not exactly clear because the $95,000 borrowed is the value at time zero. So that's not going to make much sense. What you really want to do is to take the future cash flows to time 120 months to understand precisely what remains to be paid. So the order is to put this in here, go back to the calculator. You can clear it, or you can leave it because you want the interest rate still. So you can make 120N. The PV is what we want, but the payment is $649.57. And we can make it a negative. FB is 0, and now compute the PV. And there you go. And I think most people did that. Most that attempted it. So the final answer questions. Good job, Ricardo. Okay, that's all you have to write on your paper in your solutions. Okay, let's go to number 2. No questions? No comment on my sound. Is it really bad? You could tell me if it's bad. At least get me some feedback on the sound quality. Okay, the present value of an annuity using an effective annual discount rate, so that's another word to reflect interest rate, correct? 12% is this amount. The annuity consists of 9 annual payments, with the first 4 being $8,000. Now you want to find out what are the remaining payments. So what you have are 2 annuities. You have an annuity due, which is the first 4 payments, and then an annuity that's delayed. A deferred annuity. So all of it should be equal to 40,000. So for people who are trying to visualize this, No comments on my sound quality? Can you hear that? I need some feedback. You can hear this. Okay, so these ones are 8,000. Oh, I did too many. And I forgot about the first one. So, to correct myself, so because the payments start up front, so it's an annuity due and annuity in advance, the remaining payments we're trying to find end early. These are the first four. And then these are the remaining five. So I'm going to write this as a string of equations. And the first four are going to look like the annuity due formula. These are annual, so I'm going to use the effective rate given. And that's that. And then the unknown is in an annuity that starts here. So the valuation should be one period before. That's how the formulas work, remember? So the valuation should be here of this part. You can call that part A, and this part B if you want. Let me do colors. Do colors. So this is this part, and then the second part is here. Thank you, Ricardo. Okay, so we're going to have an annuity with the same rate. The rate didn't change. For 5 payments. So the challenging part is where everything is. You have to be able to position everything where it should be and realize that this amount over here needs to be computed and discounted 3 periods. Because it's PB3. All right, so why do I make these problems more challenging than just straightforward questions? Well, first of all, you have all your notes at your disposal. Second of all, things exist like Chegg and now ChatGPT, which I tested this exam against ChatGPT to find out it cannot solve these problems. So that's the idea. I have to make problems that you can solve, but not any AI or Chegg or whomever. I also put them in as images, so you couldn't cut and paste them easy enough. So I'm trying to make this exam have integrity. You know, if you did well in this exam, you worked independently, you should feel really proud with your achievement, all right? And that's the kind of feedback I want to provide to you and to the administration. So, okay, so what do we do now? We need to find that payment. I mean, I can call it PMT or I can call it C4, or X, you know, I can call it different things. I'll call it PMT. It helps us. Looks like our calculator key. So now you just got to be careful about putting this in your calculator the most efficient way. This is an annuity due. So it means I can put everything in my calculator in begin mode very quickly and get the answer. So use begin mode and treat it like it's a regular annuity, but begin mode. So you've got to remember, if you're going to use begin, then you're going to use 4 in N and then 12 in interest, and PV is what I want, 8,000 in payment, and 0 in FV, and then compute PV. And what do you get? When you're done, turn to N mode, or you're going to be messed up. So putting that in, clearing my TVM keys, I put 4 as the periods, 12 as the rate, 8,000 as the payment, 0 in FV, and compute PV. So that's my PV. Nope, that's not my PV because I forgot to put in begin mode. So second begin, second set, but I can still just ask for the same answer. So compute PV, that's the answer. All right, so that's my answer for the red part, the first set of, first annuity. So what I can do is put that into make it a plus and store that in 1. Oops. Oh, I lost it. Compute PV. So make it a plus and then hit store 1. So now it's in storage, number 1. I can make a note on my sheets here. The answer was 27,214,65, and there's a bunch of decimals which I'm going to keep by storing it in number 1. So now, before I continue, I'm going to simplify things. I'm going to take this value and combine my terms, right? Because this has been reduced to 27,000 and this is 40. So I'm going to subtract both sides by 27, by this amount. So now it's time for algebra. So the FINA stage is done. Now it's some algebra that I have to do. So I'm going to reduce each side by this amount that's in storage. All right, minus both sides by that amount. In other words, moving it to the other side, and what do you get? So I guess I'm going to put a negative on it. Well, let me write this number in. 40,043.69 minus, recall 1, and that's my left side now. I need to turn my calculator back to N mode before I forget. Okay, let's do that again. 40,043, 69 minus recall 1. I'm going to store that in 2 in case I make a mistake. So that's my store in 2 value. Okay, so let's write that down. So now I have 12, 829.04 equals, these cancel, of course, and that's just going to equal this thing over here. It's easier, right, with my iPad, if you're using your iPad, and it just becomes that. So what remains is to simplify this so we have just an annuity here, and then this will be like our PV. When we put these numbers together, this will be the PV for an annuity to solve for this. So you see the value of the calculator. This is what I'm trying to emphasize and get you to use. So that's another reason why I ask questions like this. I force you to use your finance calculator. It's the most efficient way to get your answers. Am I proving that yet? So what I'm going to do is multiply both sides by 1.12 to the power of 3. And of course, on this side, it'll just cancel. And you get 18,000. So this number isn't store, right? So let's do it on the calculator. I'll show you all the steps. So now I store this in 2, correct? So I can recall it and multiply it by 1.12 to the power 3 with brackets around it, and I get this number. I can store that in number 3. So for the record, I stored this number in 2, and then I did this multiplication. So this is, I store everything just in case, you know, I make a mistake and I want to try it again. Everything is stored. Now it's stored to keep all those decimal places, so we have the same answer. If you made just rounding error, I mean, you still could have chosen the right option, and the options are different enough that a rounding error would not make you think it was a none of the above, right? So if you did something like that, let me see it, because I'll give you the points. You know, if you picked a none of the above for being off by a decimal place, in any of the problems, let me know. Okay, so that is now just equal to this. And that is an annuity, my friends. So for this annuity, I'll do this in blue. For this annuity, make sure you're in N mode. And you're going to use 5 in N, 12 in interest. PV will be recall 3. And then you can compute payment. Well, you should probably, let's put 0 in FE just to be sure. And what do you get? So I have that in recall 3. So I'm going to do clear TBM, 5 periods, 12 is still the interest rate. Recall 3 is my PV, 0 is FV, and I compute the payment. And that pretty much is $5,000. It is if you round to decimals and cents. So I can write that the answer is $5,000. The answer was B. And the first one, did I circle the right answer? Was C. How's it going? Any questions so far? Remember, if the screen looks blurry, just refresh. Are you trying this while we go along? You should feel comfortable. With everything that I'm doing. It should all be a review. Okay, so clearly I'm going slower than you should have gone on the test because I'm going detail by detail and I'm making it pretty. But you could do this all within the time of the test. I asked for 4, so maybe we can finish the last 2, but it looks like it's going to take me a while. So what I'll do is I will finish the other half of this test and post it for you. And you guys can see it, okay? But I have to stop at the end because I do have a meeting, 5:30. Okay, next problem. All right, so we have been given a rate and we need to find which one of these are equivalent. So I'm going to do all of them. However, you probably in respect for time, in regard of time, you probably just stopped when you got the right answer. But I will do them all. First of all, what were you given? You were given the stated rate per year compounded quarterly. We know it's stated because the statement, the reference year or the reference period is not matched to the compounding frequency. So you know that they're just quoting it or giving you the simple interest over the year. So they've given you R 1 quarter. And so from here, you can find the quarterly rate directly by dividing R 1 quarter by 4. So, okay, so that's going to be 0.12 divided by 4 is 0.03. All right, so none of those, so that's the effective quarterly rate per quarter compounded quarterly, so it's not 3.2%. So this is not it. So let's check the second one. So by just doing that, we've ruled out an effective rate of annual rate of 12.5. So let's check that one. So given an effective quarterly rate, and we want the effective annual rate, one of these makes 4 of these because this one is smaller. So to find it, you would take the quarterly rate to the power 4 minus 1. And that would give you the effective annual rate. Oops, that didn't work. So 1.03 to the 4 minus 1. Aha, look familiar? That is the right answer. So this is the answer, but I'm going to keep going, right? You should have time to test them all. What is the equivalent rate per 6 months? So this is the effective 6-month rate per 6 months compounded every 6 months. So that's also a effective to an effective conversion. So that would be it's easier to use the quarter and make it a half. So what's the relationship between these two? Which one is smaller? Quarters are 3-month periods. Semi-annual periods are 6-month periods. In fact, it's 2 quarters in 1 6-month period. Now you could have also used a 4 here and a 2 here, but you see that exponents can be reduced on either sides to be 2 and 1. If I had it as 4 and 2, they could be reduced. So I'm going to go with 2 and 1. And I'm going to continue with this number. I want to find that. So it's going to be APR 1, 2, 1/2. So the reason I do it like this, right, is just to remind myself the relationship. But then I pull away and I use the formula 1.03 to the 1/2 minus 1. What did I do wrong here? I went backwards. I want to get this one. Yeah, it's squared. That didn't make sense what I was doing. It's 1.03 squared minus 1. And is it 6%? No, it's not going to be 6%. I can already tell you. 1.03 squared minus 1 is 6.09%. So this one is also eliminated. Aha, and now this last one, the technique that I show you should allow you to convert to compounding frequencies in a fraction of the year or to compounding frequencies in more than a year. And this is the example right here. Every 5 years, we want the rate that compounds every 5 years. So what's the relationship? The relationships are the same. Same pattern of relationships, in fact, for this one. And again, you already have your answer. You could just stop there, but I could also give you problems and ask you to, which of the several options are true. Maybe more than one of them will be true. Not on this exam, but on another exam. So I want to give you that feedback. So what I need, or what this is here, is actually a stated rate. I know it's stated because it says per year, but it compounds every 5 years. So in fact, this is a rate that looks like R with a 5, because that represents the length of the compounding interval, right? Just like over here, this was a quarter, this was a half, this is the length of the compounding period in years. So it's 5 years, and because R is only on a year basis, it actually has to be multiplied by 5 to make any sense. So this is what we want. Well, actually, no, what am I saying? That's not what we want. We want actually this one. But how do we relate it to the effective rate? Because we can't do anything without the effective rate relationship, right? So I want this one. And how am I going to get it? I'm going to get it by taking the effective 5-year rate, same subscript, but that's over 5 years. And I want the simple interest. So it's just dividing that by 5, which will be the rate over a year. And the thing that I was telling you before was I was saying that I was getting to say that we could also write that relationship this way. So this would represent the effective 5-year rate. Yeah. Let me write it a different way so it looks more like what we were doing. Well, I guess this looks like what we were doing, but the other way to see this is I could write this as, because what I'm doing is I'm dividing, 1 second. I need to cough. All right. We are usually dividing by the reciprocal of this subscript. So that's the same as writing it like this. Sorry. It's the same as writing it like this. So yeah, this can be confusing. That's why I'm giving you some practice. So what do I want to do? We need to find the stated version. So I want this. So that means I need the effective 5-year rate, which is easy because I have it already. It's over here. We calculated it. This one, and it's part B. So let's take it. So let me write down some notes here. This is the stated one that we want. And this is the stated one that we want. And to get EPR 5, I'll use the same approach. What are we given? What do we need? We want EPR 5, and we're given, well, from part B, we have EAR. So 5 effective annual rates is the same as 1 factor of the 5-year rate. So let's just take this number, 1.125508881. We don't have to worry about decimals because there aren't any. And that should be EPR. So 5. And then we're going to take it and divide it by 5. And you get 16.2. How did I do on that? So again, so 1.125508881 to the power 5 years of compounding minus 1 gives you the effective 5-year rate. So it's like 12% a year, or 5-year period of 80%. That's what it's saying. It makes sense. I mean, it seems dramatic, but it makes sense. Is the number? So that's what it's saying, is that 5 years compounded of 12.5 is 80.6 every 5 years. But now we're going to convert that into an annual average rate. And you do that by dividing it by 5. I hope you're getting this, because this one is over the whole 5 years, but ours stated rates are always in terms of a year. So, and it's just simple interest. So we just divide, no compounding. This, however, was all in compounding. And you do not get the answer. You don't get the 16.2%. What do you get? It's 16.1. It's very close. 16.12. Tricky, tricky. Okay, any questions so far? So we're done. So this one doesn't work. So I did a thorough answer both. Any question? Okay. And that's the complete answer. Number 4. So look, I'm going to finish 4 in an hour and a half. The first 4. I'm doing it as slowly. As slowly as I can. So you understand. So what you're supposed to do in this problem, number 4, was use your knowledge of this terminology, premium and discount, right? So we learned that if I equals C, so that if the interest rate or discount rate equals the coupon rate, then the bond sells at par. That's the terminologies. In other words, the interest payments are made through the coupon. And so you pay $1,000, that will end up being the price. So you pay $1,000 to get your money back at the end, but in between, you get your coupons at the interest rate, or the yield, at the current yield to maturity. But if your yield is higher than the coupons paid, what will happen to the price? So to ensure you get a yield that's higher than that coupon rate, if this is how it's arranged, then the bond must do what? So the coupons are not enough to compensate for the yield, right? The opportunity cost of the purchasing of the bond. So then they have to be sold at a discount. It's called a discount bond, so it's less than 1,000. If it's less, the coupons exceed, then the bond sells at a premium, so it's more than 1,000. And so in this case, I told you about a bond that sold at par, but then the yield it's currently selling at a price where the yield is now 9%. So there's no change in market risk. In other words, the coupon stays the same. The coupon rate stays the same. The coupon rate here was 10% in the original bond. The original pricing, right? So C was 10% because it is, the coupon rate, remember how we calculated that? The payment was equal to the rate times 1,000. So to find the rate, you just take the payment divided by 1,000. So that's why the payment was 100 divided by 1,000. The coupon rate is 10%. So currently you have 9% interest and a 10% coupon. How did I say that? 10% coupon, 9% interest. Did I say it like that? 10% coupon stays the same because there's no change in risk. You're still going to get that rate for your coupon. In other words, there's no default risk. So you are in this territory, the premium bond. Any questions? And people who answered that, most of them got it, so that was great. All right, so we still have time to do a couple more questions. So you learn a lot doing this exam? I mean, you're supposed to know things before doing the exam, but doing an exam helps heighten your awareness and understanding. So I guess this one was probably the most complex for people. Well, 5 and 6. All right, so the timeline's really going to matter here. So we want, for CDQ products, their dividend policy should reflect company growth. They indicate that the first quarterly dividends, so dividends are quarterly, so let's make a note. Quarterly payments convert all your variables to quarters. First quarterly dividend will be 80 cents per share 3 years from today. But after that, dividends will increase at a rate of 2% until the end of the 6th year and then grow at 1.2% thereafter. What share price should you pay for such a stock if you expect an effective annual return of 15% per year? All right, so let's pause on drawing the timeline. We need a quarterly rate, so let's get it. We need an effective quarterly rate. So we're going to take our the growth given are in quarterly rates already. We'll take these as quarterly effective rates. But we need to make our effective annual rate of return, the interest rate for our formulas, has to be changed from an effective annual rate of 15% to an effective quarterly rate. And we do that by partitioning it in the exponents -1. So now we got the hang of this. And we'll store that in our calculator. So to put that in the calculator, 1.15 to the power, you can say 0.25 minus 1 and store 1. So that's in the calculator as a decimal value. So 0.035558. Okay, now I want to find the price. I'm going to make a timeline. And I can make it in years. I can also make it in quarters. That's way too big, isn't it? Let's do this. So in the third year, that'll start 80 cents. And then there's going to be a growth period starting there to the end of the 6th year. Remember, the marks indicate end of year. So the G in here is going to be 2% effective. After that, it goes to 1.2 per quarter. And this is what they anticipate that firm will exist forever. These are the assumptions we make. Okay, the firm will continue to exist, and it will continue to grow. And this will be indefinite. So all I need to know for my formulas, what I have is I have an annuity in here, and I saw many students were just using the basic time value of money, or the NPV approach for each of the cash flows in here, and that's one way. So I'll show you the way I like to do it with annuities. So I'm going to just mark 1, 2, no, that's a little bit more space. 1, 2, 3, 4, 1, 1, 2, 3, 4, 1, 2, 3, 4. Because you can see how many there are. You could actually calculate it. I gave you some instructions in the last, in Unit 1 at the end of the notes, how you can count. But I'll just do it. I'll do it straightforward right now. I only have a couple minutes. All right, so what you want to do is you want the annuity that would be starting here, one period before that first 80 cents. So that would be, you could call it PV 2 3/4 of a year, or in terms of quarters, it would be the 11th quarter, because this would be the 12th quarter, right? If I'm going to use quarters. Just trying to make it, in quarters. Let's go like this. Okay, so you can call it, like I say, PV 3 3/4 years, or PV 11 quarters. And you want to find that annuity, because actually it stops, right? It stops here. So all you need to know is how many there are. There's going to be 4, 8, 12, payments, right? So the last one is going to be at the end of the 6th. So it's going to be going from here to here. You got to be careful for the payments. If you go back and look at my lecture notes, I explain if you want between here and here, there are 12 intervals, but you have to add one if the payments start here. If the payment goes inclusive from end to end. So there's actually 13 payments, and you could count them. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So I'm going to make a note that there's 13 payments. Let me do that again. And then the other one is just a perpetuity, and it's growing. Oh, I have to specify, this is not just 13 payment annuity. This is the 13th payment annuity with growth. So what I'm going to do, you guys can get going. I'm going to finish this one. I am going to finish this problem, and then I will post the rest later so you can watch them all, right? But I'll say good afternoon to you for now, because either you have a class now or you got to get going. It's getting dark. All right, so I'll let you go for now, and I'll finish this, and then next class either, well, I'll contact you about the next class if we're going to meet, or I'm going to prepare a video that you guys can watch because of that conference that I have, and that my voice isn't so great. I don't really want to make too many videos. It should be better soon. So can I say good afternoon? Have a great afternoon. Bye for now.